Okay, this video is on circles. A circle is a set of points equidistant from a fixed point on a plane. So all the points on that circle are the same distance from a certain point, and that point is called the center. The center is the point from which all other points of the circle are equidistant from. Radius is the distance from the center of the circle to its edge. And the diameter is the distance from one edge of a circle to the other side through the center. Okay, so we use R for radius and D for diameter. Okay, we have two forms for a circle. This first one is called the standard form of a circle. X minus h squared plus y minus k squared equals r squared. The center is HK. So HK represents the center of the circle. R represents the radius of the circle. And x comma y is a point on the edge, any point on the edge. Okay, so this little example we have here, x minus 4 squared plus y plus 3 squared equals 25. The center would be 4 comma negative 3. Think of it as the opposite of the number inside the parentheses. See how it says x minus 4? So there's a minus 4, the opposite would be positive 4. Or you could think of it as the number that will make it 0. Positive 4 would make that 0. 4 minus 4 would make it 0. And the other one, it says y plus 3, so we're going to take the opposite of plus 3, so it'll be negative 3. Or negative 3 plus 3 will give you 0. So it's a number that'll make it 0 inside the parentheses. Okay, the radius, because the standard form says r squared, we want the number squared that gives you 25. Well, that would be the square root. So the square root of 25 is 5. This happens to be a perfect square. 25 is a perfect square. But if that 25 were another number that's not a perfect square, say 12, then the radius would be the square root of 12. You can either write it in decimal form if you're going to graph it, or you might want to write it in simplest radical form. Square root of 12 will be 2 square root of 3. Okay, we have another form. It's called the general form of a circle. And basically what we do is we perform the exponentiation and we simplify the equation. So that just means if it's squared, we write it out twice in FOIL. So we get rid of the exponents and we simplify. Okay, that might seem confusing. We'll show you an example. This first problem is, let's just go ahead and learn how to graph a circle. What we're going to do is we're going to find the center and the radius, and then we're going to plot the center, and then we're going to plot 4 points, a distance of r units from the center. So the easiest way to make a circle is to find your points, r units. So let's say r is 3, you're going to go 3 up, 3 down, 3 left, 3 right. It's too hard to go 3 at a diagonal unless you have a ruler. So that's why we go left, right, up, and down. And then we can draw our circle the best we can. Okay, here's our first example. X minus 2 squared plus y minus 1 squared equals 9. First thing is, what's our center? It's always HK. So we're comparing it to x minus h squared plus y minus k squared equals r squared. Our center would be 2, 1. And the radius would be the square root of 9, which is 3. Okay, so we've plotted 2, 1. And now you're going to plot 4 points. You're going to go 3 up, 3 down, 3 left, 3 right from the center. Okay, and then just try to make a circle using those points of the circle. It's okay if it's not perfect. And that's it, we're all done. Okay, next problem. Okay, now we want to find the equation of a circle in standard form given the center and the radius. So all we're going to do is replace h, k, and r with the given values into the standard form. So example 2, find the equation of a circle in standard form having a center of -4, 5, and a radius of 3. Okay, so we're going to substitute h, k, and r. Here's our standard form. The -4 and 5, that's your h and k. And then the r is 3. So remember, h is the x value, k is the y value of our center. All right, plug those in. So it's x minus -4 squared plus y minus 5 squared equals 3 squared. Just simplify that a little bit. Minus and negative turns out to be a plus, and then 3 squared is 9. That's our final answer. Okay, so that's standard form. Here's another one. Same thing. We want to write it in standard form. This time I have fractions. The center is -1/2, 3/5, and the radius is 5/7. Okay, here's our standard form. Our h is -1/2, our k is -3/5, and our r is 5/7. Again, minus and negative is a plus, and then 5/7 squared means 5/7 times another 5/7, which will be 25/49. Again, this is standard form. Okay, this next problem is general form. So general form didn't have any parentheses, right? Okay, so we're still going to do the same thing. We're going to replace the we're going to replace the h, k, and r into the standard form, and then we're going to work it out. Instead of writing it out with a squared, we're going to write it out twice in FOIL and then bring all the terms to one side. Okay, so here's our center, 3, -2, and r is 7. So replace the 3, -2, and 7 into the standard form. And that gives you x minus 3 squared plus y plus 2 squared equals 49. Okay, so if it's in standard form, we're all done. That says general form. So we're going to write that x minus 3 out twice, and the y plus 2 out twice. Now we need a FOIL. So this is kind of busy work, to be honest with you. So that's x squared minus 3x minus another 3x plus 9. So it's x squared minus 6x plus 9. The second product is y squared plus 4y plus 4. Put the squares first. So we're writing it in order. Add the like terms. So that's x squared plus y squared minus 6x plus 4y plus 13 equals 49. One last step. We've got to bring the 49 over to the left-hand side. So subtract 49 on both sides. And then work that out. X squared plus y squared minus 6x plus 4y minus 36 equals 0. Okay, now I'm kind of going to go backwards. Instead of finding general form, they're going to give us general form. And then we're going to be asked to find the center and the radius. The process that we're going to use for that is completing the square. So I'm sure you remember completing the square. We'll go through it. Okay, so our first step is to kind of group it. Put the x's together. Try to leave a space because we're going to complete the square. And then put the y's together. Again, leave a space. And then move the constant to the other side. Okay, in this case, I label it as e, but that's a constant because it doesn't have a variable, so that gets moved to the other side. We just want it out of the way. Okay, and then we're going to create the perfect square trinomials on the left side by completing the square so that we can rewrite it in standard form. Okay, here's our first problem. Our first problem of this form. X squared plus y squared minus 4x plus 6y minus 12 equals 0. Okay, the minus 12, we're going to kick it to the right-hand side, right? So that gets moved to the right-hand side, it becomes a positive 12. And then let's group the x's and the y's together. So we have x squared minus 4x, again, leave a space. Y squared plus 6y, leave a space. And then the 12 becomes positive on the other side. Okay, now completing the square. Remember the process? You take 1/2 of the x term, and then you square it, right? So in this first problem, first trinomial, 1/2 times -4, what's 1/2 times -4? Right, -2. And then what do? We square it. That gives us 4. So that's the number that we're going to add to complete the square. But don't forget, whenever you add to one side, you have to add to the other side. So plus 4 on the left, plus 4 on the right. All right, next trinomial, 1/2 times 6, that gives us 3, and then square it. That's a 9. So 9 is the number that we're going to add to both sides. Plus 9 on the left, plus 9 on the right. Okay, now we have two perfect square trinomials. So if we factor those, they give us a binomial square. And actually, you don't have to really work that hard. The number that's going to be written inside the parentheses is the number before you square it. So the first one is going to be x minus 2 squared. The second one is going to be y plus 3 squared. And then you add the 12, 4, and 9, and that should give you 25. Now we have our center and our radius. Our center is 2, -3, and our radius is 5. All right, here's another one. Again, we'll group it. Put the x's first, the y second. Move the 45 to the right-hand side, becomes negative. Now the second variable, the y squared, it doesn't have another y, so that just stays by itself. It's actually easier. Okay, Half of 14 is 7, and then we square it. 49. So we're going to add 49 on the left and on the right. So on the left-hand side, it's going to be x plus what number? It's a plus because it's a plus 14x. It's going to be the number before you square it. So it'll be plus 7. And then the y squared stays the same. And negative 45 plus 49 is 4. So now we can write our center and radius. Our center is negative 7, 0. And our radius is 2. This one has fractions. Same process. Move the constant to the right and rearrange the terms. So the 2 becomes positive. We put the x's together and the y's together. Now we complete the square. 1/2 of negative 3. What's 1/2 of negative 3? Right, negative 3 over 2. You can put a 1 underneath the 3 if you want. So 1 times 3 is 3, and 2 times 1 is 2. So negative 3/2. And then we square it. That'll give us 9/4. So 9/4 on the left, 9/4 on the right. Now the 7. 1/2 times 7. That'll be 7 over 2. And then we square it. 49 over 4. 49 over 4 on the left. 49 over 4 on the right. Okay, now when you write it as a binomial squared, it's always going to be the number before you square it. So the first one is going to be x. Well, what do we get? We got negative 3/2, so it's going to be minus 3/2 squared. And the second one is going to be y plus 7/2 squared. And then when you add your 3 numbers on the right, you should get 33 over 2. Now our center, that one's not too bad. Our center is 3/2, negative 7/2. And then our radius, well, we want to take the square root of 33 over 2. But we can't leave it like that. We can't leave a number with a radical on the denominator. So it's called rationalizing the denominator. You multiply the top and bottom by square root of 2. So that'll give you square root of 66 over 2. So that's our radius. You could put in your calculator if you need it in decimal form, maybe if you were going to graph it, which is approximately 4.1. So if you type that into your calculator, you should get a little bit over 4. Okay, so we got it. There's our center and there's our radius in either form. Depends on the direction, so always be careful with directions. Finding the equation of a circle in standard form, given the center and a point on the circle. A little bit different this time. Last time they wanted the standard form, they gave us the center and the radius. This time they're giving us the center and a point on the circle. Okay, there's a couple different ways we could do this. We could use the distance formula. We'll try to make it as easy as possible. Okay, so the center is HK, right? That's looking at number 1. and the point, any point is of the form x comma y. So what we're going to do is we're going to replace the h, k, x, and y into the standard form, and then simplify. This will give us r squared. Okay, then when we write the answer, we're only going to replace the h, k, and r squared into the standard form of a circle. Okay, I know it looks a little complicated, but this is the easiest way to do it. We only have one formula, right? And we're going to stick with it. All right, example 8. Find the equation of a circle in standard form having the center 3, negative 2, and passing through negative 1, 4. All right, let's write down our information, our h, k, and x and y. Our center is 3, negative 2. I like to write a little h and a little k above that so I know which one's which. And then the x, y, that's our negative 1, 4. So now we're going to replace the h, the k, the x, and the y into the standard form, and then simplify. Okay, it says x minus h, so our x is negative 1, and our h is 3, so it's going to be negative 1 minus 3 squared. Same thing with the y and k. 4 minus negative 2. The only one we don't have is the r, and that's okay, that's what we're looking for. We're looking for the r squared. So negative 1 minus 3 is negative 4, and the 4 minus negative 2 is 6. Negative 4 squared would be 16, and 6 squared would be 36. Add those, that gives us 52. And we're just about there. Now, when we write our answer, we're only going to replace the h, the k, and the r squared. Don't put in the x and y. So there's our answer. X minus 3 squared plus y plus 2 squared equals 52. Okay, we do have to review this midpoint formula. It's because the next problem after this, we're going to do one more after number 9, number 10, and we're going to require that we use the midpoint formula. So you might remember it. To find the midpoint between 2 points, it's x1 plus x2 over 2, comma, y1 plus y2 over 2. Let's do a little example, and then we'll talk about the next problem. So find the midpoint between the 2 points, negative 1, 4, and 5, 8. Okay, I like to write little x1, y1 above the first point, x2, y2 above the second point. So remember, they're not exponents, they're subscripts. So if we use our formula, x1 plus x2, that'll be negative 1 plus 5 over 2. And y1 plus y2, that'll be 4 plus 8 over 2. Simplifying that, 4 over 2 and 12 over 2, and then 4 over 2 is 2, 12 over 2 is 6. So that's the midpoint between those 2 points. So you might be asking, why do we need the midpoint? Okay, here we go. Okay, last problem. Find the equation of the circle in standard form for which the line segment determined by 4, negative 5, and 6, 3 is the diameter of the circle. Okay, so we have 2 points that are on a diameter. What we need is the center. If we have 2 points on a diameter, the center, therefore, would be the midpoint. So we're going to find the midpoint using these 2 points that we have given. Okay, so just like the last problem, use these numbers to find the midpoint. So that's 4 plus 6 over 2 and negative 5 plus 3 over 2. So that will give us 5, negative 1. That's our center. Okay, we have a center, and then we need a point, and you could use either one of those 2 points that we have given as our other point. You could use the 4, negative 5, or the 6, 3. It's totally your choice. I'm going to use the 6, 3. So use the center and either point to find the equation. So I'm using my center as 5, negative 1, and my point as 6, 3. So now we do it just like we did the previous problem, like number 8. 5, negative 1 is our h and k, and 6, 3 is our x and y. We're going to insert those into the standard form to find our r squared. So 6 minus 5 squared plus 3 minus negative 1 squared equals r squared. 6 minus 5 squared is 1. 3 minus negative 1 is 4. Square them both. That's 1 plus 16, which is 17. That's just about it. We got our r squared. Now we can write the final standard form, just using h, k, and r squared. Okay, this video is over. I'll see you here for parabolas.